Hi there. So in this video, we're going to start going over some topics in geometry. Now, we're not going to go through a lot of geometry, but what we're going to do is look at some formulas for what are called measures. All right, and just to give you a preview, I've got to talk in general right here, but we're talking about things like perimeter and area and volume are the three kind of measures that we're going to look at. Okay, so we need to talk about two basic vocabulary terms to start talking about these measures. All right, there's the idea of being in two dimensions. And so these are the objects that are within a plane. And so if you're not familiar with that word plane, you can just think about it as being like a piece of paper. Okay, uh, okay, so objects that are within a plane or two-dimensional are things like rectangles, okay, and triangles. There's going to be another object that we talk about called a trapezoid. I'll explain that in a minute if you've never heard of that. And also circles are within a plane. Okay, and so adding in the trapezoids, we'll look at those four basic shapes and talk about different kinds of measures for them. Okay, now with three dimensions, these are objects that are within space. Okay, I said within space. Okay, and so to help, so these are just typical three-dimensional objects, but we'll just look at basic ones. Okay, we'll look at what we'll call boxes, all right, or spheres are in three dimensions. Okay, and then the idea of what's called a cylinder, and then a cone are the basic objects that we'll look there. Okay, and the way we measure, the reason I'm pointing this out is the things that we can measure in two dimensions are different than the things that we can measure in three dimensions. And so whenever we think about this, we'll need to think about, at least behind the scenes, think about what dimension we're in. That also affects the kind of units we get in our answers. One other thing about this video too, in this video I'm just going to give us formulas, and then hopefully I can get time to make a separate video about where the formulas come from, because they actually make a lot of sense if you look at them carefully. So for now, let's just focus on two dimensions. So we want to talk about different measures of objects in two dimensions. And there's two basic measures. Make sure you realize they're very different from each other. There's some slight correlations, but not really a whole lot. Okay, and so there's the idea of what's called perimeter, and there's the idea of what's called area. And these are different ways to measure a two-dimensional object. Okay, and so what perimeter is it's the length around an object. Okay, so it's like, let's just draw a rectangle here really quick. So let's see if I can get this to work. Okay, so there's a rectangle, and so the idea of perimeter is that you can imagine starting at one corner, or starting at any place on that rectangle, and if you walked around that object, if you walked around the sides, okay, and then went back to where you started, the question is, how far did you walk? And so that would be the length around the object. All right, and so that's the idea of perimeter. All right, and now one thing to point out about this, think about this, if the sides were measured in feet, then whenever you walked that first length, you would have walked so many feet, and then you would have walked another number of feet, and then another number of feet, and then another number of feet. Okay, and so the key thing about perimeter is the units for perimeter. The units are the same as the sides, okay, like that. And so perimeter has the same units that you start out with. We'll see that that's slightly different with area. All right, so what area measures is it basically is a measure of the amount of space inside the object. Okay, so make sure you realize perimeter measures kind of what's going on outside the object or on the edges of the object, but area measures how much space is inside of that object. All right, and so the easiest way to think about what area is actually measuring is, I can't draw that exact rectangle again, but let's try to get close to it. Okay, so that's pretty close to where we're at. So imagine this being a room in your house and you want to carpet it, all right? And so what ends up happening is you can get, but you need to know how much carpet you can get. So whenever you go to the store, they're going to have a little carpet square, okay? And it'll be like 1 foot by 1 foot, all right? And so I don't know why that didn't identify that. Let's try that again. Like that. And so the idea is you want to figure out how many of those carpet squares will fit in here. So you just start lining these squares up inside the room. And so you put one in, okay, and then you can come here and then you get another one and you start lining those things up, okay, like that. And I'm having trouble getting it locked into place there, but anyway, you get the idea. And then what you do is you count the number of those squares that would fill the room. And so that's the idea of what's going on with area. Area is how many of those squares would actually fit into the room there, all right? And so that's the idea of area. Okay, and so the idea here, what area really does is it counts these number of squares that go in, and this will help you understand the formula for a rectangle too. But you end up having all these squares, and so what the area is, the area, we use the capital letter A to denote it. It's the number of 1 unit, and I'll explain that phrase in a minute, by 1 unit squares that fill the object or fit inside. So that's what area is in general. And so you got to be careful of that, because a lot of times when I ask people what area is, they'll say length times width. And we will see that is a formula for this particular object that we have right here, a rectangle. But for other kinds of objects, there's different kinds of formulas for the area. So length times width is a formula for area for a specific type of object. But what area actually is, it's the number of 1 unit. Gosh, I wrote that really sloppy, didn't I? So it's the number of 1 unit by 1 unit squares that fit inside the object. Okay? Now, if you're wondering what this weird phrase is, 1 unit by 1 unit, it's because we measure in different kinds of units, like inches or feet or something like that. So if my sides are in feet, this would be the number of 1 foot by 1 foot squares that fit inside. Okay, if my sides were measured in centimeters, then the area would be the number of 1 centimeter by 1 centimeter squares that fit inside. Okay, so that's the reason for that strange terminology there. By the way, too, some typical letters to use for area and perimeter. I've already used one. Capital A will denote the area, and then up here on perimeter we'll use the letter capital P. Will denote perimeter. Okay, and so that's the idea. And I know it seems a little overkill that I keep talking about it, but people get really confused about the difference between perimeter and area. All right, and so try to get that in your mind early. Perimeter measures the length around an object. Area measures how much space is inside by counting the number of squares that fit inside. Now, because we're talking about squares inside, the units for area has what are called square units. Okay, and so if my sides are measured in feet, then if I go and compute the area, the units will be square feet. And some people will abbreviate that as feet squared, that I'll show you in a minute once we start doing some calculations. Okay, so first let's just talk about perimeter. Okay, there's not really a whole lot of formulas for perimeter, because you just got to remember the perimeter equals the distance around the object, right? And so to get that, if you think about that last picture I drew, you just add the side, just add all the sides, okay? And so we get that. But there is one special perimeter formula that we actually use a lot. So there is a formula for rectangles. Now, if you're not sure about what a rectangle is, a rectangle. Let me draw one for you here. And so we have this rectangle, okay? And so notice what makes something a rectangle is that it has two parallel sides here and here, and then it has another pair of parallel sides here and here, and they are all connected by 90-degree angles, or what we call right angles. All right? So these two sides are the same length, these two sides are the same length, and there's a right angle around them. Okay? Now, because these two sides are the same length, all right, we usually call that the length. And so I write it as a script L just because my regular L's look like ones. Okay, so you might want to use a capital L if it's not very clear what you're writing there. All right, so that's called the length. It's usually the longer side. It doesn't necessarily have to be. All right, and then notice the other two sides also have equal length, and so we usually call that the width. And so we'll denote that with W. And if you use a capital L, you might want to use a capital W for that as well. Okay, so now if you go and compute the perimeter of this thing, okay, well, let's think about this. Let's do that diagram that I did a minute ago. So let's think about starting over here, though, okay, and walking around the object this way. Okay, so when I go from that lower left corner to the lower right corner, how far have I walked? I've walked L units. Okay, and then I go from the lower right corner to the upper right corner. Well, there I would have walked W units. And remember, to get perimeter, we just add the sides. So L plus W so far. And then I would walk back across the length again. So I would have added in another length. All right, and then to get back to my starting point, I would walk along that left edge right there. That would add in another W. Okay, like that. Now just think in terms of some basic algebra. Here we have a pair of like terms. L plus L, that's 2L. Okay. And then W plus W is 2W. Okay, so just be careful. This is just for a rectangle, but it's a nice formula to be aware of. Okay, now tied into this is the idea of a square. Squares are special rectangles. Okay, all the sides are equal in a square. Okay, and so with a square, let's see if I can get it to draw one for us. Having trouble here. There we go. So now we have a square, and so in that case, we usually, since all the sides are equal, instead of using L and W, we usually use the letter S for that. You don't have to, though, okay? But we'll use the letter S. Well, think about that. Whenever I went to compute the perimeter by this basic notion of walking around the edges, I would just have S plus S plus S plus S. And so in the special case of a square, we can simplify that formula and say that the perimeter is equal to 4S, like that. Okay, so again, just remember that formula only applies for a square, though. All right, but don't forget that general idea of perimeter, that with perimeter, we simply just add all the sides together. So if you're given a triangle, triangles, there's not a general formula for the perimeter of a triangle, but we just add the sides if we know all the sides are given to us. Now, area is very different. There are lots of formulas for the area of two-dimensional objects. Okay, and so let's just get started. Like I said, I'm just going to give us I'll explain them a little bit, but I'm hoping to make a second video to really explain where the formulas come from, because they actually do make lots of sense if you look at them carefully. Okay, but anyway, so for the area of a rectangle, all right, so the idea here is, let me just explain this one briefly. Okay, if we go back to that, so remember we have a length and a width. So here we have the length, and here we have the width. Okay, if we go back to that notion of what area is, it counts the number of 1 unit by 1 unit squares. So I would start laying out those squares, those carpet squares, all right, like that. So I'd end up with all these little carpet squares in here. Sorry if I'm not drawing them perfectly. Pretend like those are squares, okay? And then in the next row, I'm going to end up with just as many along that, okay? So, and on down the line. Okay, so by the time I have it all laid out, I would end up with a grid pattern like this. All right, now don't worry about having to cut squares and stuff like that. We'll talk about that later, but let's just say that filled out perfectly. So what's the idea here is that on each row I have L squares. Oops. I have L squares along each row, but then I have W rows. So I would have L plus L plus L plus L plus L, and I would repeat that addition W times. Okay, and so that's where that formula comes from. For a rectangle, the length, the area is equal to the length times the width, which is what a lot of us know. Okay, now I want to point out something about the units too, real quick, and do a quick example here, just to show you this, but mostly just to point out why we get square units. All right, let's get another rectangle drawn. Okay, and so let's say that the length here is 20 inches, and the width is 8 inches, like that. Okay, and so now to get the area, like we said, it's just length times width. So we would just do 20 times 8, which is 160. Now remember, as I've said, with problems that have units, we should answer in units. So the answer to this problem is not 160. We need the units. All right. Now, I've done this before. I've said whenever you use formulas, you can just plug in the numbers and you don't need to include the units as long as you remember what the units of the answer is supposed to be. But just to show you something here, and this is a nice thing to point out, is that units in algebra act just like variables. Okay, so you can put the units in there and it'll just help you see why the answer has the kind of units it does. Okay, like that. So I'm really, right here, I'm really multiplying four things. I have 20 times inches times 8 times inches. And so remember, it doesn't matter what order I multiply things in. So I could group together that 20 and that 8, and then I could multiply the inches, or then I could group the inches and the inches. So 20 times 8 is 160. The key thing is, what is this part right here? Well, that's something times itself. And so remember how we express something times itself? We use the second power, like that. All right, and so there's those square units. This is inches. The way we would technically say this is inches squared, but that's the same as a square inch. So the answer to this problem is actually the area is 160 inches squared, or some people will say 160. They'll abbreviate square with SQ, and then the abbreviation for inches, like that. All right, it's up to you how you want to answer those. The main thing in this example is to explain why area has squared units. It's because whenever you go and do your multiplies, those units actually get multiplied times each other as well. Now, just like with perimeter, if we have a square, we can simplify this. Okay, and so let's see. If for some reason I'm going to have trouble recognizing one of my squares there. Let me try it one more time again. There we go. Okay, and so so remember, if we have a square, we just usually use the letter S. Okay, well the key thing is with the square, all the sides are equal, so I have an S there too. So it's like the length is equal to S and the width is equal to S. And so if I wanted to compute the area, that would be length times width, but the length is S and the width is S, like that. And so I get A is equal to S squared. Okay, so so that's a special formula for a square. But you can, since squares are just special cases of rectangles, you can also use this formula right here for the area of a rectangle. Okay, I just realized I forgot to circle something important there. One other thing too, just some people may have seen this slightly different. Instead of using the terms length and width, some people use the terms base and height for the dimensions on a rectangle. And so up here, instead of length, they might use B for base, and then for W, they might use H, like that. So you may have seen this. Don't worry too much about it, but you may have seen this formula. The area of a rectangle is base times height. Either one of those are equivalent ways to say the same thing, and it could help you with understanding the formula for triangle. So yeah, let's look at a triangle. And so the key thing is that prefix right there. So if you're not unaware of this, a triangle has three sides, okay? And so technically it's a closed object with three sides. All right. Now, to understand this formula, I'm going to draw a special kind of triangle. It's called a right triangle. Okay. And so let's see if I can get it to do it. Uh-oh. Yeah, there we go. Okay. The reason this is called a right triangle is it has a right angle in it. All right. And so the key thing, so with any triangle, there's two basic dimensions that we're interested in. This bottom side right here, we call the base, and we'll denote it with a small b. Some people use a capital B, like I did on the last slide for the rectangle. All right. And then so this is called the base, and then the distance from the base up to the top, we call the height. Okay, and so we'll use H for height, like that. Well, the key thing is here, if you look at this carefully, a right triangle is actually, if I draw its mirror image around that longest side right there, this thing right here is a rectangle. Okay, and so now this is a special case for a right triangle, but this means that this is half a rectangle. So then its area should be half that of a rectangle. All right, so in terms of area, remember a moment ago I said another way to think about the formula for the area of a rectangle is base times height. I use capital letters, but I'm going to use the small letters since we use that. Okay, like that. And then since it's half of a rectangle, we get 1/2 base times height, like that. Okay, and so some people also will think about these as being over 1 and multiply all those fractions together. And so some people write the formula as B times H over 2. Those are two equivalent ways to say that. Okay, and so this carries over to more than right triangles. So I just explained, and it needs a little bit more explanation to show that I'm going to save for another video. But anyway, so we can take this as given now. The area of a triangle is 1/2 base times height, or BH over 2. Okay, and so just to do a quick example here, say I have this triangle right here. Say I draw this, and say I tell you that this base is 10 feet, and then sometimes we'll draw the height in here and give it a number. Sometimes, because it's hard to fit it in, we'll draw this right here and say give the height that way. So it just depends on where you're looking. What I'm trying to say is sometimes we draw it over to the side. Sometimes we'll draw that dashed line and put it right there. It just depends on who's writing the problem and how much room they have to get that in there. Okay, but if I want to find the area, okay, then we know the formula for the area of a triangle now, 1/2 base times height. And so make sure you realize this is the base and this is the height. So we have 1/2 times 10 times 3. Okay, so remember we're multiplying three numbers. We can multiply any two together we want, and then multiply times the third. 1/2 times 10 is pretty easy. That's 5 times 3. And A is equal to 15. Now, why is that not the answer, though? We need units. Since we're computing area, the units aren't just feet. They're square feet, or feet squared. Okay? like that. And so that would be the area of that rectangle. Okay, so now an object that some of you may not be aware of is what's called a trapezoid. Okay, now first of all, trapezoid are four-sided objects. Okay, and then they have exactly one pair of parallel sides. And I know some of this vocabulary might be much for you, but if we go back to the rectangle, like that, all right, we call these two sides right here parallel, and then the widths are also parallel. Okay, so that has two parallel sides, and so that's not a trapezoid. Okay, and so let's think about what this would mean. We have exactly one pair of parallel sides. I can't get my program to recognize a trapezoid. So we have one pair of parallel sides, but this is also a four-sided object, so these other two sides have to connect like that. All right, so sorry, I didn't draw that very well, did I? Now make sure, one thing to realize here, these two sides right here don't have to be the same length, and these two sides aren't the same length either. Okay, so this formula is a little, I can't explain this area formula without going into more detail back on the triangles. And there's another shape that got skipped over called a parallelogram that I'll talk about in the explanation video. But anyway, with the trapezoid, there's three basic dimensions that we need to know its area. There's its height. Okay, so just like with the triangle, sometimes we'll draw it over to the left, sometimes we'll draw a dotted line in there to give the height. All right, now the other important thing is the length of those two parallel sides. All right, and so this top length right here we'll call A, and this bottom length down here we'll call B. Just make sure you realize B is the entire length of that bottom side. Okay, so for now we're just going to have to take this formula as given, and if you're curious, I'll explain why the formula comes out the way it is. But it starts looking like the triangle formula, 1/2 h. Okay, remember we have base times height. The thing is that A and B are acting like are both type of base, and so what we do is we take 1/2 the height, and then we multiply that by the sum of the two bases. All right, and so that is the formula for the area of a trapezoid. Okay, like that. So let's just do one quick example, and you'll see it's not too bad. It's just a matter of recognize when you have a trapezoid and how to find those different dimensions, and then how to get the area of it, of course. Okay, so say this top length here is 3 centimeters, and the bottom length down here is 10 centimeters. And say I tell you that the height here is 4 centimeters. Okay, like that. So in terms of that formula, this is acting like the A, this is acting like the B, and this is acting like the height, H. Like that. And so the key thing is we recognize it as a trapezoid. And so its area is 1/2 h times A plus B. Like that. And so I have 1/2 the height, that's 4, times, in parentheses, A plus B. Like that. All right, and so just now we just follow order of operations. We do those parentheses first. Okay, these are 3 multiplies right here, so we can take any 2 using the associative property. 1/2 times 4 is 2, and then that's times 13, which is 26. Just don't stop there. First of all, be careful. A, make sure to include units. Another common mistake for people to make is to say centimeters. You just got to remember that you're computing an area, so it has square units, like that. So the area is 26 centimeters squared, or you could say square centimeters. All right, now we need to talk about another important type of object, which is a circle. And we all probably have an idea of at least what a circle is. It's just a round object, right? But we need to understand how you actually make one to understand some of the terminology associated with circles. So the idea of a circle is you think about having a string of a fixed length, okay, like that. And we'll denote that with the letter R, and we'll use the letter R as an abbreviation for the word radius. Okay, now what you think about doing is pinning that piece of string down, and then grabbing a pen and holding that string tight, and then just tracing all the way around at that center point. Okay, like that. I didn't draw a very good circle, but you get the idea, right? And so let's see if I can get a better one drawn on there. So yeah, there we go. So let me erase this, and we can get a better picture to draw on based on that. Okay, and so the idea is that we have that center point, like that, and then the thing is, the center is not technically part of the circle. It's just the place. It's a point of reference for the circle, and then what the circle actually is it's all the points on this boundary right here. Okay. Now there's another related quantity that you might be aware of with circles, and that is if I take a point on one end and I go through the center and go to the point that's opposite on the circle, then that's going to give me a length right here, and we denote that length with the letter D, and D is an abbreviation for the word diameter. Okay, like that. And so then if you think about it, though, in that picture, D is actually composed of two segments, the segment from here to here, but that's a radius. That's just as big as the radius, and a segment that's there to there. So the diameter is composed of two radiuses. So there's this fundamental basic relationship is that D is equal to twice the radius, or D equals 2R. All right. Now, to start talking about perimeter and area, there's a different term that comes from history for circles. It's called the circumference. Okay, and we'll use the letter C to denote it, like that. And all the circumference is, it's just another word specific to circles for perimeter. Okay, so what circumference is it's the perimeter of a circle. All right. Now, there's something important that came about in history that happened is if we go back to this idea here of having a circle, all right, and looking at the diameter instead of just the, okay, and this happened a long time ago. People wanted to know what the relationship was between the diameter and the circumference. So remember, the circumference is the distance around. It's the perimeter, so it's going to be the distance around that thing. So it's that distance there in green. Okay. Well, what people ended up doing is they would actually draw out a circle, and then they would take a piece of tape or string or something and actually measure that diameter. And then they would start wrapping that diameter around the circle. So it would go maybe to right here and then stop. And then they would get another piece of string just as long and go around part of the way like that. And so there's two diameters, and then they would go a little bit further, and what would happen is they would always fall a little bit short. All right? And so you get to this idea that the circumference of a circle is about equal to 3 diameters, but we always fall a little bit short. And this is an amazing fact. No matter how big or how small that circle is, the circumference is always just a little bit more than 3 diameters. All right, and so you could have a circle that's the size of a dime, or a circle that's the size of the equator of the Earth. And no matter what, anytime you measure the diameter and the circumference is just over 3 diameters. So people got interested in, well, exactly, if I want to know exactly what number I multiplied times the diameter, then what would that number be? Okay, and it ends up being a very complicated problem and a quite complicated number. Okay, and what ends up happening, you probably heard of this number before, but that number is equal to, it's a strange number, and so people have made up a special symbol for it. Sorry if my screen is jumping around. And so people have made up a special symbol for it, and it's a Greek letter, and it's denoted like this, okay, and it's denoted, and the way you pronounce it is pi. You pronounce it just like the dessert that most of us like, but it's actually a Greek letter that's spelled P-I, okay. Now, pi is a strange number. So first of all, let me just give you that formula. So for a circle, Its perimeter is denoted with C for circumference, and it's equal to pi times d. All right, like that. Now, some of you probably, or all of you might be somewhat familiar with pi. Pi is what's called an irrational number. It has an infinite decimal expansion that never ends. So most of us know it as 3.14, but there's actually a lot more to it. 159 is what I know off the top of my head, but that expansion goes on forever. You should have a calculator that has a pi key on it. It just depends on what calculator you have. You have to look around for it. It's usually on the little blue TI calculators. It's its own key up toward the on the upper left side, and then on graphing calculators, they're usually a second feature. But if you hit that key, try it out. If you hit that key and hit enter, your calculator, and again, this is approximately equal to, because it's not exactly, it has an infinite decimal expansion. So on my calculator, it gives me 3.141592654. Okay, but even that's not entirely correct. There's an infinite number of decimal places after that. And this has been such a problem for so long. These days, people have calculated pi out to billions of decimal places. It's just an interesting computing problem about how you can get that. That's the reason people study it in such detail. So the key thing is about talking about all this, do not, whenever you do a calculation with pi, do not use 3.14. Okay, I call that the elementary school use of pi. All right, and so use the pi key whenever you do calculations with this. Okay, now also remember, since the diameter is equal to 2 times the radius, some people use this formula. They would say pi times 2 times the radius. But typically, whenever there's a whole number in an algebraic expression, we'll write that out front. And so C is equal to 2 pi r is the way they'll write it. So you can use either formula, and I would know them both because of some problems will give you the radius, but some problems will give you the diameter. And so you want some versatility. If you're only going to try to memorize or know one, know this one right here. And then if the problem gives you the diameter, just remember to divide it by 2 to get the radius. Okay, and the reason I advise that is that the area formula for a circle is given in terms of just its radius. All right, so we want to talk about the area of a circle, and I'm just going to give you the formula right now. I'll explain it a little bit after I write it, but for the area of a circle, it's pi times r squared. Be very careful when using this formula. Remember, with order of operations, we square first and then multiply. So this square only applies to the radius, not to pi. All right. Now, this might not be the cleanest explanation, but just to give you an idea here, is first of all, where this formula comes from, is think about if I had a square, okay? We were using S to describe the sides a minute ago, but say that each one of the sides was R, okay? Then the area of that square would be R times R, which would be R squared, right? Okay, so now let's look at a circle, okay? And so if we look at a circle here, oh my goodness, I didn't pick that up at all, did it? All right, and so let's try that one more time, see if I can draw it a little bit better. Okay, so there's our circle, all right, and here's my center, okay, and just remember the distance, let me do this in a different color. So the distance out here is R, right? So I could draw a square right here, okay, and notice that right here is R. So the area of this blue region right here is R squared. Okay, so that area right there of the blue region is R squared. All right, and if you think about it, I could draw 4 of those. All right, now what we're trying to do is get an idea of the area of the circle, so that would be the white region. All right, and so you can see the area of that white region is less than 4 of these R squareds. I hope you see that. I know it's, like I say, I know it's not the cleanest explanation, but each one of these squares has an area R squared, and there's 4 of them. But this white region is clearly smaller than that. So the area is less than 4 R squared. Okay, but you can see there's quite a bit of space being left out. All right, and so because of all that space that's left out, the area of this white region actually ends up just being just over 3 of those r squareds. So, uh, so I could take each one of those r squared areas. So that's this right here. Okay, like that. And if I took 3 of them, it would almost fill out that entire region. I'd fall a little bit short. And so why am I pointing this out about being just over 3? That's what pi is. Pi is just over 3. So that's kind of a diagram to start illustrating where that formula comes from. Like I say, I'll be the first to admit that's not the cleanest explanation, but that is basically where that formula comes from. Okay, now let me give you an example like you would probably see in your homework. Okay, and it'll say find the circumference and area of the circle. Okay, but here's what it's going to say. It'll say give the answer in terms of pi, then approximate it to so many decimal places. It just depends on what your book and what it says. And so I'll say approximate to 2 decimal places. Okay, like that. And so then, okay, and so the problem will probably give you some kind of circle. Now, it might only just tell you what the radius or the diameter is. But here's a circle, hopefully, yep. Okay, and so say I tell you that here, let's do one with the diameter. So say it tells you that that distance right there is 8 feet. Okay, like that. So what is that giving me in this problem? It's telling me that the diameter is 8 feet. Okay, so what does that tell me the radius is? Well, a radius, there's 2 radiuses in a diameter, so the radius is equal to 4 feet. To get the diameter from the radius, you multiply by 2. So to go backwards, you divide by 2. All right, so we need to give the circumference. All right, and so C is equal to, you could say pi times D or 2 pi r, however you want to do it. All right, and so they gave us the circumference or the diameter here, so this is going to be pi times 8. And like I said earlier, usually if there's a whole number with the pi attached to it, we usually reverse them around. So this is equal, the circumference is equal to 8 pi. So that's the answer in terms of pi. This is what's called the exact answer. I can't do any better than that. Now, to get so then we need to approximate it though. So on my calculator, I would just type 8, and then I would hit that pi key, and then hit enter, of course. All right, and you should see a decimal that says 25.1327. Here, let me, I'm going to erase this in a moment, but here's what my calculator gives me. Hopefully you tried it, and you can see whether you got it, except it's 25.13274123. All right, but what does the instructions tell me to do? Approximate to 2 decimal places. So that would be here in the hundredths. I look one place to the right, that's smaller than 5, and so then to write the approximation from these directions, I would say 25.13. All right, now what's missing here? I'm not done with my problem yet, and so what am I missing? I'm missing my units. Okay, so you got to remember, what kind of units does this have? Well, circumference is the distance around. It's a perimeter, and so perimeters have the same units as the given lengths, and so the circumference is in feet. So that circle is about 25.13 feet long. Okay, now for the area is equal to pi r squared. Okay, so now we need the radius, but we already found it. It's 4, so we have pi times 4 squared. Okay, that's pi times 16. And since we have a whole number in front of pi, we'll usually write that as 16 pi. All right, and then just to get the approximation, I would type 16, hit the pi key, hit enter, like that. Now this one, whenever I get the approximation on my calculator, it says 50.26548,246, like that, but I'm approximating the two decimal places right here. This number is 5 or larger, so I need to round up, okay? And so for my approximate answer there, I would type in 50.27. Now this is an area, so what are its units? They would be square units. So there's the answers to that problem. All right, so now we're ready to talk about a three-dimensional measure. We're just going to talk about one called volume. There's another one called surface area that's not covered in this class, but it's called volume. All right, and what volume is it's a measure of the amount of space taken up by a three-dimensional object. Okay. And just like with area, remember area technically is the number of 1 unit by 1 unit squares. That volume is equivalent. It's the number of 1 unit by 1 unit by 1 unit cubes that fill the object. Okay? Like that. Okay? And so one key thing here is that volume has cubed units. Okay, like that. And what we're going to do is we're going to talk about 4 basic three-dimensional objects and get formulas for them. Okay, so the first one we could loosely call a box, okay, or the technical term is a rectangular solid. But thinking about a box will make it a lot easier. If you think about it, a box has 3 basic faces. It has its front face, like that. It has a side face, like this, and then it has a top face, like this. Okay, and if we really wanted to stress the three-dimensionality, we could draw dotted lines in behind it. Okay, so the reason it's called a rectangular solid is that I have a three-dimensional object, so it's a solid. But if you notice, each one of these basic faces are rectangles. Okay, and so we have these 3 basic measurements. We call this the length, we call this the height, and the width, and we call this the height. All right, like that. And you could probably reason this out. The reason is it works just like the rectangle. I could think about trying to fill this object with a bunch of little cubes like that, and what ends up happening is all 3 of the dimensions end up getting multiplied. All right, and so the letter we use to denote volume is V, and so for a rectangular solid, its volume is just you multiply the 3 dimensions. So we say length times width times height. Okay, and so just as a quick example and to illustrate the units here, say I'm basically just going to draw the same thing here. By the way, too, while I'm drawing it too, remember it doesn't matter what order you multiply things in, so it doesn't matter what you call the length, width, and height. Okay, so say this is 10 inches, this is 12 inches, and this right here is 4 inches. Okay, like that. And so then if I wanted to get the volume, I just multiply the 3 dimensions. So I have 10 times 12 times 4, and so that's notice it's easier for me to multiply these and then multiply by 10, so I can do that by the associative property. So I got 10 times 48, that would be 480. Okay, now what are the units? I said up above, volume has cubed units. All right, so that tells you something right there. And so I just take my regular units and I make them cubed. And the reason for that, if you're wondering, is what have I done? Remember, my units act like variables. So in this multiplication, although I didn't write the units, I could have, and then I would have had inches times inches times inches. Anything times itself 3 times is the third power there. Okay, so mathematically, that's where those cubic units come from. All right, and so that would be the volume of that rectangular solid. And just a quick mention of a special case of a box, we call that the cube, and that's whenever all sides are equal. So it's the 3-dimensional analog of a square. Okay, and so you can think about a die that you play games with. I didn't draw that very well, did I? This should be a little bit smaller there. Okay, but we usually use S to denote the side whenever they're all equal, like that. And so if I thought about doing, if I wanted to compute the volume of this, I would do length times width times height, but those are all the same. And so in the special case of a cube, I just get V is equal to S cubed. All right, now most of us just think about the word cylinder, meaning what we really mean by a circular cylinder, but there in mathematics there's more general types of cylinders, so whenever we want to be really clear, we say a circular cylinder. So the idea of a circular cylinder, now I'm drawing in 2 dimensions. I'm trying to draw a 3-dimensional object in 2 dimensions on my screen. The screen's 2-dimensional. So there's always some distortion here whenever you do this. But the idea is that you have this circle that. So it doesn't look much like a circle, right? It's because it's distorted from that dimensionality. But then you think about extending that circle through space, and then down on the bottom you have the exact same circle again. Okay, like that. So being a circle, it has a radius, like that, and then there's also a height that'll affect the volume. All right, I'm going to show you more where this concept comes from. But in the case of a circular cylinder, the volume ends up being pi r squared times h. Okay, so notice here, you can kind of see the general concept. Where else have we seen pi r squared? That's the area of this circle up above or below. Okay, and so let me do an example real quick though, and then I'll explain that concept. But say I have an actual cylinder here. I don't have room to write it, so I'm just going to put it up here. Say that I tell you that distance right there is 4 inches, and then I form a circular cylinder out of that. Okay. Like that. All right, and say that I tell you that the height here is 10 inches. Okay. So, and then in terms of doing the volume here, we have pi r squared times h. And you were given the radius r. Be careful. Some problems will give you the diameter, so you got to remember to half it. All right. But so we have pi. The only thing that's squared there is the radius. So 4 squared, and then times the height, 10. Okay, like that. And so 4 squared is 16, and then times 10. And so be aware of directions, and I'll put this on test too. Always give the answer first in terms of pi. This is called the exact answer. There's absolutely no error in it. But then whenever I go to approximate it, I got to round it somewhere. I'll usually tell you to round to 2 places, all right, unless there's a good reason to round differently, all right. And so if you type that in on your calculator and round it to 2 places, hopefully you see that we get 502.65. Okay, what are my units here? I'm doing volume, and I had inches, so I have you can say inches cubed. Those are technically called cubic inches. All right, like that. But make sure to give both. Don't just give the approximation. All right. Now, this is just good to know. It's not really in your homework so much, but this is a good general concept to understand. Okay, so this general concept deals with what we call in mathematics a prism. So the idea is that we have one shape. It doesn't matter how strange that shape is, but I could have some shape right here, okay? And what I can do is I can extend that shape through space, okay, like that, and connect those, okay? Now technically this right in here is the back side, so it should be dotted, okay? But you have this 3-dimensional object, but it's basically composed of this 2-dimensional object then extended through space, okay? And notice that that line's not even straight that I connected them with. But if I can find the volume of that strange shape, and it doesn't have to be a strange shape. I'm just showing you a general concept that it doesn't matter how that shape is. But if you can compute the area of that top piece right here, so if you could get that area A and not measure the length of those slanted lines, but measure the height of that object. This is an amazing fact in geometry. So if I could measure that height right there, like that, then the general concept is that the volume is actually equal to that area times the height. Okay, so going back to that cylinder, just to help you understand that formula a little bit better, whenever we have that cylinder formula like that, remember we got V is equal to pi r squared. Where did that come from? That came from the area of this circle right here. And then that circle was extended through space like that by a height of h. So then I just multiply it by h. Okay, and so that's where that formula comes from. It's a very powerful general concept in geometry too. What this also says is, as long as it was at the same height, I don't need those sides to be straight. This cylinder right here, as long as it has the same height and the same circle on the top and the bottom, as long as those heights are the same, they have the exact same volume. All right, anyway, I know that was a bit of a sidetrack, but it's a good thing to be aware of. Okay, now relating to this is what's called a cone, and this is technically a circular cone. Okay, the idea of a cone is that you have a two-dimensional object. If it's a circular one, then it looks like this, and then there's a point. You don't extend that circle through space. You find a point above the center, and then you extend lines up to that. So most of us are familiar with an ice cream cone. So the way I drew it is just an ice cream cone flipped over, right? All right. So we have that idea, and so again with the we have a radius, and then we also have a height. This is another powerful thing in geometry, is that the volume of a cone is always 1/3 the volume of the related prism, okay, or cylinder if you want to think about that. All right, like that. And so, okay, so for the volume of a circular cone, then what would we do? Its related prism is a circular cylinder, and we know what that volume is. It's pi r squared h, or we just learned that. All right, and so the cone is going to be 1/3 of that. All right, like that. And there is that general concept too, that if it doesn't matter what shape the base is, okay, like that. If I form a cone from it, like that, then and I know at what height this thing is right here, then if I can compute the volume of that base shape, this right here, okay, then so if I know that area right there and I know the height, then the volume of that cone, that strangely shaped cone, is going to be 1/3 times the base area times the height. Total side note there if you don't quite get that, but we will use this, all right, like that. So let's do a quick example of that so you can see it in action. All right, so let's say I have this cone right here. It's a circular cone, and with the dimensions that you can see in the picture. So now what's that 12 feet? You got to be careful. That 12 feet is the diameter of that circle, all right, but the formula contains the radius. So to get the radius, I would divide by 2 and get 6 feet. All right, so then if I wanted the volume, just following that formula, it's 1/3 pi r squared h, all right, and so it's 1/3 pi times r squared, that would be 6 squared, and then times the height, which is 11. All right, and so we square that 6. All right, now if you think about this, you can be clever because remember 1/3 is the same as dividing by 3. And remember, we're just multiplying these four numbers together. Is there a number in here that divides nicely by 3? And yeah, it's the 36. So remember that associative property tells me that I can regroup things, and the commutativity property. Remember, we just usually write pi out at the end, all right? And so if I do 1/3 times 36, that actually gives me 12 times 11 times pi, all right? And then 12 times 11 is 132. You could do that on your calculator if you don't know how to multiply by 11, all right? Like that. And so there's the volume in terms of pi, and then we'd want to plug that in on our calculator, 132 pi, hit enter, and to 2 decimal places, it's 414.69. And then just don't forget your units. We had feet, but we're doing volume, so that would be feet cubed, like that. All right, one more shape. I know it's a long video. All right, so I'm not sure how familiar you are with some of these terms, but there's what we call a sphere, and all a sphere is it's basically a ball, okay? And it's the three-dimensional analog of a circle, all right? And so the idea here is that we have a circle. Think about the globe if you need to instead of a ball. So this is like the equator, and then you have another circle that encompasses around that. Sorry, I didn't draw that very well. Okay, I'm going to see if I can't get a better picture there. That's bothering me. Okay, so I'll just go with that. But then we have this kind of equatorial circle right there. So there's a good picture of a sphere. Okay, it works just like a circle. There's only one number that really determines what's going on that sphere. It's the distance from the center out to any point on the sphere. Like that, we call that the radius. Okay, so make sure there's very small spheres like a marble. Its radius might only be like 10 millimeters, and then there's the radius of the Earth. That's like 4,960 miles. All right, and so there's just a basic formula for the volume of a sphere. It's a little bit strange looking. It's 4/3 pi r to the third power, like that. Okay, so if I wanted to compute the volume of a sphere, since we have that pi in it, we'll always need to keep that in mind. But let's get us a sphere drawn. All right, and so let's say I give you this, that, and say I tell you that the radius, let's do a circle that has a radius of 10 miles. By the way, too, I mentioned this in an earlier video. If you don't know what an abbreviation for units are, I mean, I would encourage you to look them up, do a search on the internet or in some book. But if you don't know, it doesn't really matter. I could call these anything I want. Just whenever I compute the volume, I just write those to the third power. All right, so in terms of the volume here, we have a sphere, and so we have a formula for the volume of a sphere. Okay, what are we given in this picture right here? That's the distance from the center out to the sphere, so that's the radius. So they gave us that the radius is 10 miles, like that. And so we have 4/3 pi times 10 raised to the third power. Okay, that's 4/3 pi times 1,000. 10 to the third power. You might need to type that in on your calculator if you don't know that. All right, now this one's a little bit strange, but not too bad if you just remember some basic stuff. Here we're dividing by 3, but 3 doesn't divide into 1,000 evenly, so I want to use fractions here. Okay, so remember we usually just write the pi out at the back, so we have 4/3 times 1,000, but since we're multiplying fractions, I'll want to write it over 1. And so remember, to multiply fractions, we go straight across. And so I just ran out of room. I'd keep going down if you're writing. And so we have 4,000 over 3 pi. So that's the answer in terms of pi for the volume. And now to do that on your calculator, you just type it in just like it's written. So you type in 4,000 divided by 3, and then times, and hit that pi key. All right, and hopefully you tried that so you can see if you get the same number. But we get 1,488.79, and then what is the units there? Miles cubed, or cubic miles. Okay, and so that's how you do the volume of a sphere. All right, I know this is a long video. Hopefully you got through it. What we're going to do now, you want to get these basic formulas down and practice with them, because what we're going to do next is start talking about how to solve different kinds of geometry problems with shapes using algebra. Okay, and so I hope that helps. Thanks for bearing with it, and let me know if you have any questions. All the best.